Welcome to qnawire.
We're going to have a pendulum, which is going to have a length equal to 0.75 meters, which is going to be displaced horizontally on delta x by 5.0 millimeters, which is 5 times 10 to the minus 3 meters, and then it is going to be released. So the initial position of this pendulum is going to be, essentially, we're going to have a very small angle over here. This is going to be our starting point, and we're going to have, at some point in time, we're going to pass through this position, at which we're going to have a maximum velocity right where we're going through the center over here. What we can say from this picture is that we're going to have a change of altitude, delta on y, due to the displacement that we have on x. And this change of y is going to be related to the length that we're going to have over here and the value for delta x that is given to us. Simplifying this triangle, what we can say is that we're going to have this angle theta. Over here, we're going to have 0.75 meters as a hypotenuse, and down below, 5 times 10 to the minus 3 meters. So what we want to know is what would be the change of height corresponding to the normal condition. Remember that since this is attached to the string, the total length over here is going to be 0.75 meters as well. So we want to know what is going to be this distance to get the change of height. So in this case, what we want to know is, first of all, what is going to be the angle theta. In this case would be arc, which cosine corresponds to 5 times 10 to the minus 3 divided by 0.75. This angle theta would be a very small angle of, in this case, an angle that is almost 90 degrees, since we are almost having a straight line. The one that is going to be super small is going to be the angle on this position. And the result here corresponds to 89.618 degrees. With this, we can calculate what is going to be, this is delta x, what would be the y prime position. Let me put it in green as well. Let's call this y final, which is going to be the quantity over here. We know that y final would be equal to 0.75 times sine of theta. So taking the sine of this angle times 0.75, we're going to get that y final would be 0.74 998 333. This implies that the change on the y-axis would be equal to 1.66852 times 10 to the minus 5 meters. And this would be our delta y. Why we did this calculation? Well, simple, because in this way we can calculate the maximum velocity through energy conservation. At this point, we're going to have only potential energy. And this is going to be equal to 1/2 times mass times velocity squared. So the calculation of velocity, in this case mass and mass cancels out, would be equal to 2 times gravity times the maximum height that we're going to get, and taking the square root. So this is 2 times 9.81 meters per second squared times the maximum height, which is this value that we just got, 6,852 times 10 to the minus 5 meters. And the final velocity is 0.0180832 meters per second. This would be our maximum value for velocity that we can get on this pendulum. So with this information, the only thing that we have left is calculate the time that it takes to reach to reach this velocity. And remember that the oscillations of the pendulum, I'm going to write down over here, I'm going to exaggerate a little bit the distance, are going to correspond, a full period of oscillation corresponds to the movement for going all the way to the maximum amplitude on the other side and going back into its initial position. That means that to reach the middle point, the time that is going to be required is going to be the period of oscillation divided by 4. And for a simple pendulum, the period of oscillation is going to be equal to 2 pi times the square root of L divided by G. This is going to be valid since the value of the angle that we have on this position is going to be very small. So the small angle approximation is going to work well on this situation. So the period of oscillation would be 2 pi times the square root of the length, 0.75 meters, over 9.81 meter per second squared. Which gives us 1.7304 seconds. And taking the value of t divided by 4, this is going to give us 0.4326 seconds. And this is going to be the time for maximum velocity. Time. And with that, it would be all. Thank you very much, and have a good one.